Welcome to C and C++ programming under EPG Pathshala. Today we will start with module 28 functions. Function is a very good programming tool which is given to the programmer. Using functions we can make our programs more readable, compact and easy for use. If in a program multiple lines of code is used again and again, then we can group this particular code and give it one name which will be a function name. Whenever we require this group of lines of code in the program, we can give the call to a function. So, a code will be written only once and it can be called in the program multiple number of times. Using this, our program will become more structured, modular and compact. Even it will be easier for other users to understand the logic of the function. In future, if you want to make any changes in our program or any changes in the code that we have written, then the change has to be done only in the function definition. Other parts of the program where the function is called, no change will be required. So, maintaining the program code will become much more easier. Again, using the functions, we can display or do some small tasks inside the function routine. So, it will be easier to perform the function. Here, we have to make sure that one task will be performed in one function. We cannot make complex codes and 2-3 tasks grouped together inside the function. Again, we have to be more careful while using the global variables inside the function. As far as possible, we are not going to use the global variables inside the functions. Our functions will be used again and again inside the same program or in other programs also. We can make a routine or the library of the user defined functions, and in any program where we require the function, we can give the call to that particular function. So, it makes our programs more compact. In C++, there are two types of functions which are provided. One is user defined functions and second is library functions. To make use of library functions, we should know the syntax or the prototype of the function and the header file which has to be included inside the program. User defined functions has to be defined first before they are used inside the program. Now, let's start with our module functions. A function is a subprogram that operates on data. In programming, the function refers to a piece that collects the code to perform the specific task. In the bigger project, a small programs or the functions will be written independently and then it will be collected at the last. The functions are mainly divided into two types depending on whether the function is predefined or whether it is created by the programmer. They are user defined functions and library functions. There are two types of functions in standard library functions which are defined by the C compiler, and user defined functions are defined by the user. Now, let us see the learning objective of this module. We are going to learn about the standard library functions, we will learn about user defined functions, we will learn about call by value concept, we will learn about call by reference concept. We will study about return by reference, we will learn about the constant arguments, we will know about the friend and virtual functions, and we will study about the recursion concept. The standard library functions are part of standard library that is made available by the compiler. The C++ standard library present a rich group of functions for performing common mathematical calculations, string manipulations, character manipulations, input output, error checking, etc. The C++ standard functions are provided as a part of C++ programming environment. There is no need for the standard library function to declare and define them. Whenever the standard library function is to be used in the program, then the corresponding header file in which the standard library function is defined has to be included inside the program. Here we are giving the list of some of the C++ standard library header files which are listed into these slides. Just go through the slides. The character functions require cctype.h header file. Some of the character functions are string length, string copy, etc. Some of the mathematical functions are included and they are available inside the file cmath.h. Let us see a program to find the square root of a number using the standard library function. Now, let us start with the program. We will start with #include iostream, #include cmath. Here the cmath header file is included because our square root function is defined under this header file. Using namespace std, Let's start with the main program, integer main. Now we will declare our variables as double number comma square root. We will take the input from the user as C out, enter a number. We will take the number as C in number. Now we will give call to a function as square root equal to sqrt in bracket number semicolon. Now here sqrt is a built-in standard library function which is defined inside the file cmath. Here we just have to know the syntax to use that particular standard library function. Now we will display the result on the screen as C out square root of number is equal to square root return 0, and our main program will end. Now when the above code is compiled and executed, it will produce the result as enter the number. Suppose the number entered by the user is 25, then it will display the output as square root of 25 is equal to 5. Now let us see one more program to calculate the sine of an angle using the standard library function. Now let us start with the program hash include iostream. Here again we have to include the file math.h because the sine function is defined under the header file math.h. We will include the file as hash include math.h using namespace std. Let us start with our program now. Integer main, we will declare the variables first double, result, degree and radians. First we will take the input from the user as C out, enter the number of degrees, C in degrees. Now we will give the value to the variable radians as radians equal to degrees into bracket m pi divided by 180. Result is equal to sine sin, which is a name of the built-in function, inside bracket radians. Now here this particular sine function we just should know the syntax how to use it and which are the parameters that has to be passed. C out, the sine of degrees is the value of the result, return 0 and the main function will end. When the above code is compiled and executed, it will produce the result as enter the number of degrees. Suppose the user has entered the degrees as 60, then it will produce the output as the sine of 60 is 0.866025. User defined functions. In C++, it is possible for the programmer or the user to define the function of their own functionality according to the requirement of the task. The user defined functions tries to group the code to execute a particular task, and that group of code is given a specific name. When the function is invoked from any part of the program, it executes all the code that is defined in the body of the function. Now let us see how the function is defined and what are the syntax for the function definition. In C++, it is must that a user defined function must be defined before it is used anywhere in the program. If a function does not return any value, then it is must to specify the return type as word. This is because in C++ by default the return type will be integer. The syntax to define the function in C++ is as follows: the return type, the function name in bracket comma separated parameter list, starting braces, the body of the function and the ending braces. Now in the above syntax, the return type is any valid C++ data type which will denote the type of the value that the return statement of the function is going to return. The function name is any legal C++ identifier which is the name of the function. The comma separated parameter list is a parameter list of the function separated by comma. The example is integer difference in bracket integer a comma integer b. Now here we are defining the function difference where the return type is integer, name of the function is difference, and it is going to accept two parameters a and b, both of type integer. Now here even if the both parameters are of type integer, we cannot write here as integer a comma b. For each and every variable the data type is a must, so it has to be written as integer a comma integer b. Now we will start with the body of the function, opening curly braces, integer result, result is equal to a minus b, return result, and end of the function. So here this is a function which is defined by the user and name of the function is difference. So to call this particular function, we should give the proper parameter list to the function and it will be called inside the main program or inside any other function. Now we will see one more example of user defined function. we will define the function as void greeting inside bracket void. Now void is a return type. This particular function is not going to return anything and the argument list is empty, so we have written there as void. So it is not going to return anything, it is not going to accept any parameters. Now we will start with the function body, opening braces, cout hello world, closing braces. So this is a function which will be just displaying the message on the screen as hello world. It is not going to return anything, it is not going to accept any parameters. Function prototype. Function prototype is a declaration of the function that informs the program about the type of the value that is returned by the function and the number of arguments and type of arguments. The function boundary to the compiler by giving the details such as number of arguments and type of arguments and the type of return value. The function prototype declaration is almost similar to the function definition except that it does not have function body. That is, it does not contain the code of the function. It is a must that the function prototype must end with the semicolon. Now let us see the syntax of the function prototype in C++. The syntax is the return type, function name, in bracket the parameter list, semicolon. The example of the function prototype is integer difference inside bracket integer a comma integer b semicolon. Here the integer is a return type, difference is the name of the function, integer a and integer b is a parameter list for the function. The second example is integer fact integer semicolon. Here integer is a return type, fact is the name of the function and in bracket it is going to accept one integer. One thing you have to notice here is inside the argument list only the data type is mentioned and no variable name is mentioned. In function prototype only the data type is essential, variable name may or may not be present. If there are 2 or 3 data types that has to be given, then it has to be separated by comma as integer, comma integer, comma integer. A function is called or invoked or executed by providing the function name, which is followed by the parameters that are being sent to the function. It is must that the function calls that tries to return values need to have the position in the main program for the return value to be located. Sometimes there may be a function that does not expect any argument, then it is invoked by giving the empty parenthesis. Example is result is equal to sum in bracket a comma b semicolon. Here sum is the name of the function, a and b are the parameters and the return value of this particular sum function will be stored into the variable result. Second is result1 is equal to fact inside bracket n. N is passed as a parameter to the function fact and the return value will be stored into the result1. The next is print opening closing bracket semicolon. This print function does not return anything and it does not accept any parameters, so our parameter list is empty. The return statement. A function finishes when either a return statement is present or when the last statement in the function is executed. In general, a return statement is used to finish a function whether it returns a value or no. The return statement can be useful in two ways. They are an exit from the function is caused as soon as the return statement is encountered and the control will passes back to the operating system, which is the caller of the main program. Second, the return statement is used to return a value to the calling code, that is, the return statement can be used in function to return a single value to the calling program. Here we have to note that from a function a single value will be returned back to the main program or the calling program. Example, return result semicolon. Now let us see a program to subtract two integers and display the result using user defined function. We will start with our program hash include iostream using namespace std. Here we are going to write a function prototype for the function subtract, as integer is a return type, subtract is the name of the function, in bracket integer comma integer semicolon. Now this is a function prototype or the function declaration. So variable names in the parameter list is not supplied, only the data types is given. So it is going to tell the compiler that the return type is integer and it is going to accept two integer variables. Here one thing to note is that in functional declaration the variable names can be omitted, only data type is compulsory, but at the time of function definition variable name and data type both are compulsory. Now we will start with our main program as integer main. We will start with the main code. Integer num1 comma num2 comma difference are the three variables which are declared. Now we will take the input from the user. Before that, we will give the message to the user as cout, enter the two numbers to find the difference. We will take the input as cin num1 num2. Now we will give call to the function subtract as diff is equal to subtract in bracket num1 comma num2. Now here num1 and num2 are the parameters to the function subtract, and the return value of this subtract function will be stored inside the variable diff. Now we will display this value on the screen as cout difference is equal to diff return 0, and our main program will end. Now let us define the function subtract as integer subtract inside bracket integer a comma integer b. Here you can find the difference. At the time of function declaration only data type was supplied, that was integer comma integer, but at the time of definition we are giving the variable names also as integer a comma integer b. Let us start with the function body. Integer result, result is equal to a minus b, return result, and our function will end. Now when the above code is compiled and executed, it will produce the result as enter two numbers to find the difference. Suppose the user has entered the numbers as minus 20 and minus 12, then the output will be difference is equal to minus 8. The next concept which comes with the functions is call by value. The default mechanism to pass the arguments in C++ language is call by value. In call by value, when the value is passed to the function, it is locally stored by the function parameter in stack memory location. If the value of the function parameter changes, it is changed for the current function only, but this change will not be reflected back to a caller function such as main. This method copies the value of the actual parameters to the formal parameters. That is, the function creates its own copy of argument values and then it tries to use them. The original copy of the argument value remains unchanged or undamaged in call by value mechanism. Now let us see a program to implement the usage of call by value concept. We will start with the program hash include iostream using namespace std. Now here we will give the prototype as function prototype as integer change integer semicolon. Now we will define the function as integer change integer a. We will write the function body as a is equal to 20 return a, and our function will end. Now here actually there is no need of function declaration, but we have given the function definition as well as function prototype. But here only definition will be sufficient, no use of function prototype. Integer main, we will start with the main code. Integer number, cout, the message will be given to the user as enter number. We will take the input from the user as cin number. Cout, the original value of the number is number, so it will display the number value on the screen. Cout, the return value of a function change is change and number. Here we are giving call to a function change where number is passed as an argument and whatever is the return value will be displayed on the screen. Cout, the value after function change is over and we are displaying back the value of a number. Return 0 and our main code will be over. Now when the above program is compiled and executed, it will produce the output as first it will ask the input from the user as enter a number. Suppose the number entered is 25. Now it will display the first cout statement. The original value of the number is number, that is 25. Now the return value of the function change is here the change function will be called where 25 will be passed as an argument. Now just notice here that 25 which is a number value that will be given to the variable or the parameter variable a. So 25 number value will be copied to the variable a. Now inside the function body we are changing that value to 20. So that 25 value we are making it as 20 and we are returning that value from the program. So here the return value will be 20 and that will be displayed on the screen. So the change which is made by the number 25 is local to that particular function. When we come back to the main program, that change will not be reflected inside the main program. So our next statement will be the value after function change is over is number. So our number value is intact, that is 25. So here one thing you can notice is the function has made the change to the local variable inside the function 20, and that change can be seen only inside the function. Once we come back to a calling program, that particular change will not be reflected. Our number value will be original value 25 and not 20. So this is the biggest disadvantage of call by value, where the values are copied to the arguments and the change will be seen only inside the function. Now let us say a program to swap two integer values using the call by value concept. We will start with our program, hash include IOStream using namespace std. Now here we will define the function as void swap integer x comma integer y. We will have a function body as integer temp, temp is equal to x, x equal to y and y equal to temp return. This is a code which will swap the values of variables x and y. X value will be given to y and y value will be given to x. Now let us start with our main program, integer main. Now we will declare two variables, integer a equal to 100, integer b equal to 200. Now we will display the message on the screen as before swap the value of a is a, cout before swap the value of b is b. So a and b values will be displayed on the screen. Now we will call a swap function swap a comma b, where the value of a will be copied to x and the value of b will be copied to y. And after calling the function swap, we will display the message on the screen as cout after swap the value of a is a, cout after swap the value of b is b, return 0. Now as you can see, before swap the value of a and b will be 100 and 200. We are giving call to a function swap which will swap the values as a value will become 200 and b value should become 100, but that change will be local to the local variables inside the function, and these local variables are x and y. So x and y values will be swapped, but once we come back to the main program, our values will be intact, a and b. So whatever changes that function has made to swap the values of x and y will not be reflected back inside the main program. Now when the above code is compiled and executed, it will produce the result as before swap the value of a is 100, before swap the value of b is 200, after swap the value of a is 100 and after swap the value of b is 200. So swapping has not taken place for the variables a and b, but it has taken place for the variable x and y. Call by reference. In call by value mechanism, the called function creates a new set of variables and copies the value of arguments into them. But in call by reference mechanism, in place of passing a value to the function being called, a reference to the original variable is passed. A call by reference method of passing arguments to a function copies the reference of an argument into the formal parameter. Inside the function, the reference is used to access the actual argument used in the call. That is, the changes made to the parameter affect the passed argument. In call by reference method, the changes are reflected back to the original values. The address of the value is passed in the function, so actual and formal argument share the same address space. Therefore, if any value is modified inside the function, then the change is reflected inside as well as outside the function, and this is the main advantage of call by reference over call by value. Now let us see a program to swap two integers using call by reference mechanism. We will start with the program, hash include IOStream using namespace std. We will first define the function swap as void swap integer ampersand x comma integer ampersand y. Now this is a change that has to be noted. Here we are passing the reference, so our variable parameters is integer ampersand, not just integer x. So this is a change in case of call by reference. In call by reference, the variables are always passed by the reference as integer ampersand. Now let us start with the function body, integer temp. Temp is equal to x, x is equal to y, y is equal to temp and return statement. And our function will end. Now let's start with the main program. Integer main, integer a equal to 100, integer b equal to 200, C out before swap the value of a is a, C out before swap value of b is b. Now we will call a function swap a comma b. Now here at the time of calling to a function, the a value will be passed to x and the b value will be passed to y. Here instead of value, a reference is created for the address of a and b. So x and a will share the same address space, y and b variables will share the same address space. So whether you change the value at that particular address using a or x is the same address location. Whether you change the value using b or y, the change will be made to the same address location. Now after call, we are printing the value on the screen as C out after swap value of a is a, C out after swap value of b is b, return 0 and the main program will end. When the above code is put together in a file, it will produce the result as before swap value of a is 100, before swap value of b is 200. Now we will call a function swap a comma b. So whatever changes the swap function makes for x and y will be actually reflected to the variables a and b. The swapping of the values x and y will make the change to a and b, and that change will be reflected inside the calling program, inside the main program. Now our next statement or next values that will be printed on the screen will be after swap value of a is now 200 and after swap the value of b is 100. So as you can see, the swapping of values of a and b has taken place using call by reference. Return by reference. The way we can call by reference, we can return the reference from the function. In C++ programming, it is not only possible to pass the value by reference, but it is also possible to return the value by reference. The example is integer ampersand minimum in bracket integer ampersand n1 comma integer ampersand n2. Now here as you can see, the minimum is the name of the function which will accept two reference variables n1 and n2, and it will return one reference as integer ampersand. We will start with the body of the code. If n1 is less than n2, then return n1, else return n2, and our code will end. Now in the above code, since the return value of the function minimum is integer reference, therefore the function tries to return a reference to x or y. When a function is called as minimum inside bracket num1 comma num2, it will give a reference either to num1 or to num2 depending on the values. Now let's see a program to implement the usage of return by reference. We will start with the program hash include iostream using namespace std. Here we will define one global variable as integer n, integer ampersand test opening closing bracket semicolon. So here the test is a user defined function which is defined which does not accept any parameters, and the return type is integer reference. We will start with the main code integer main. We will declare one variable integer number. We will display the message to the user C out enter number, C in number. Now we will give the call to a function as test opening closing bracket is equal to number. C out entered number is n, return 0, and our main program will end. Now inside this particular function, the reference is written. Now we will define the function as integer ampersand test opening bracket return n and closing bracket. Now when the above code is compiled and executed, it will produce the result as enter number 10, and it will display the message as entered number is 10. Now let's see a program to see the usage of return by reference. Now we will start with the program hash include iostream using namespace std. Here we will declare the array as double values and we will initialize that particular array as 10.1, 12.6, 33.1, 24.1 and 50.0. Now we will define one user defined function as double ampersand, which is a reference to a double, set values in bracket integer I. It is going to accept one parameter. Let us start with the function body as return values in bracket I. and our function will end. Now let's start with the program, main program, integer main. Cout value before change is endl. We will start with the for loop for integer I equal to 0, I less than 5, I plus plus. Cout vals add is equal to vals add. Now we are going to call a function which is a user defined function as set values 1 is equal to 20.3, set values 3 is equal to 70.8. Now 5 values array will be passed to a function. Out of that we are changing the index value 1 and we are changing the index value 3 of the function. So here the value at location 1, that is 12.6, will be changed to 20.23 and the value at location 3, that is nothing but 24.1, will be changed to 70.8. So inside this array, out of 5 values, 2 values will be changed at location 1 and 3. Now we are displaying the values on the screen as Cout value after change is again the for loop, and we are displaying the value back on the screen. Return 0 and our main program will end. So here we are changing the values of the array, double array, at 2 positions, that is index value 1 and index value 3. When the above code is compiled and executed, the result will be value before change will be value 0 will be 10.1, value 1 will be 12.6, 2 will be 33.1, 3 will be 24.1, 4 will be 50. And the values after change will be, now 2 location value will be changed, that is 1 and 3. Value 0 will be 10.1, 1 will be 20.3 which is a change value, 2 will be 33.1, 3 will be 70.8 which is again the change value, and value 4 will be 50. Constant arguments. In general, a constant is a quantity whose value does not change. In C++, the constant keyword is used to make program elements constant. The constant keyword can be used with variable, pointers, function arguments and return types, class data members and class member functions, and with the objects. When the argument of a function is made as constant by using the qualifier const, then its value cannot be modified. If an attempt is made to modify the value of the const argument, the compiler tries to generate an error message. Example, integer strlen inside bracket const char star p. One more example, integer length inside bracket constant string ampersand s semicolon. The two types of functions that are introduced by C++ language are friend function and virtual function. A friend function of a class is defined outside the scope of the class, but it has the right to access all the private and protected members of the class. A virtual function is a member function that is declared within the base class and it is redefined by the derived class. Recursion is a main advantage of using the functions. The ability of a function to call by itself is called as recursion. Most compilers try to execute the process of recursion by using the data structure stack. A recursive function is a function that calls itself directly or indirectly in its definition. As you can see here, the entire process of recursion is explained using the diagram. Now here, to find the factorial number of 3 where the n is equal to 3, how the recursion is going to work is shown. The procedure will be implemented as, first the call will be given as fact of 3, which in turn give the call to 3 into factorial of 2 and so on. And at the end, whenever it reaches to 0, that is the return value is 1, again the return value is returned inside the calling statement. The recursion process will start at the top level, that is as factorial 3. It tries to simplify the problem as 3 into factorial 2, where factorial 2 will again be modified as 2 into factorial 1, where the factorial 1 will be modified as 1 into factorial 0. Now once the value is reaches to 0, the factorial 0 will return the value as 1. So our statement will be 1 into 1, 1. That factorial 1 will be returned to the factorial 2, and the factorial 2 value will be returned to factorial 3, and the last result 6 will be displayed on the screen. Now this intermediate result will be stored inside the stack and complete recursion is managed by the compiler. Let's see a program to find the factorial of a number using recursion. We'll start with the program hash include iostream using namespace std. integer fact inside bracket integer n, where n is passed as a parameter to the factorial function. We will start with the function body. If n is less than 0, then return 0. If n is equal to 0 or n is equal to 1, then return 1, else return n into fact of n minus 1 and function will end. Now here as you can see, a fact function is called inside the body of the function. So this has given rise to a recursion. So our fact function is a recursive function here. Now we will start with the main program. Integer main, integer n comma result, enter the number, we will accept the number from the user as c in n, and now we are going to give the call to a recursive function fact as result is equal to fact n. Now we will display the result on the screen as C out, the factorial is result, and our main program will end. Now suppose the fact value here is 3, so the first 3 will be passed to a fact function. It is not less than 0, it is not 0 or 1, so it will again give rise to a function as 3 into fact of 2. 2 will be passed to a function which will give rise to 2 into fact of 1, which will give rise to the return value 1, and the program will be executed. When the above code is compiled and executed, it will result as enter the number 3 and the factorial is 6. Now let us see one more program to generate a Fibonacci series using recursion. We will start with the program hash include IOStream using namespace std. We will define the function Fibonacci as return type is integer, name of the function is fib, and inside the bracket or the parameter integer n. We will start with the body of the function as if n is equal to 0 or n is less than 2, return n, else return Fibonacci n minus 1 plus Fibonacci n minus 2, and our program will end. So Fibonacci series is nothing but the addition of two previous numbers. That is why our return call has come as Fibonacci of n minus 1 plus Fibonacci of n minus 2. So previous two numbers are added and that is returned using the function. We will start with the main program, integer main. For integer n is equal to 0, n less than 11, n plus plus, C out fib of n, return 0. Now here it is going to print the 11 terms of the Fibonacci series. Now when the above code is compiled and executed, the 11 terms of the Fibonacci series will be displayed on the screen as 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Now let us see a program to calculate the sum of all numbers 1 to n using the recursion. We will start with our program hash include IOStream using namespace std, integer sum integer x. We will start with our function body. If x is equal to 1, it will return 1, else it will return x plus sum of x minus 1. It is exactly on the same line of factorial function, and our program function will end. Now here we are adding the numbers, in factorial we were multiplying the numbers, only that is a change, otherwise the exact logic will be exactly the same. We will start with our main program, integer main, integer x, C out enter the number, C in x, C out sum of all numbers between 1 to x is sum of x, return 0, and our main program will end. When the above code is compiled and executed, it will produce the result as enter the number 5. Now once we enter the number 5, the sum function will be called where the 5 will be passed as an parameter, and it will give rise to the recursive function call as 5 plus sum of 4, then 4 plus sum of 3, 3 plus sum of 2, and so on, and finally it will display the output as sum of all numbers from 1 to 5 is 15. A function finishes when either a return statement is met or when the last statement in the function is executed. The return statement is used to return the value to the calling code. In call by value, when the value is passed to the function, it is locally stored by the function parameter in stack memory location. The original copy of the argument value remains unchanged in call by value mechanism. The call by reference method of passing arguments to a function copies the reference to an argument into the formal parameter. A friend function of a class is defined outside the scope of the class, but it has the right to access all private and protected members of the class. A virtual function is a member function that is declared within a base class and it is redefined by a derived class. The ability of a function to call by itself is called as recursion. Most compilers try to execute the process of recursion by using the data structure stack. The recursive function is a function that calls itself directly and indirectly in its definition.